In this video, I'll be helping you with the ALEKS problem type called graphing an ellipse given its equation in standard form. Before I get started on this example, let's take a short detour to look at the standard form of an ellipse and its different pieces. All right, this is a short sidebar to talk about the parts of an ellipse that you're going to be asked to calculate. And before we look at an ellipse, I would like to start with a circle and then see how that turns into an ellipse. We have the standard form here for our formula of a circle, x minus h squared plus y minus k squared equals r squared, where hk represents the center of a circle, and the r that's being squared is the radius from that center. An ellipse is similar to a circle, except that it appears to be stretched. And from the standard form of an ellipse, we can see that it still has that center, hk. However, the stretching occurs as a result of being divided by a squared, which gives us the length from the center out to the ellipse, which we can see here as a, the square root of a squared, and b squared, which is similar, but the distance from the center in the other direction is b. But notice it's still addition, and that where we did have the radius squared, an ellipse will always be 1. I would also point out that the a and b are always chosen such that a is greater than b. And you can see in this example that the a squared is under the x term, so it has been stretched horizontally. If the a squared was under the y term, then the ellipse would be being stretched vertically instead of horizontally. But for this example, I'll keep it horizontal where the a term is under the x value. For terminology, a is the major axis, so the length of the major axis is 2a, and b is the minor axis, which has a length 2b. Along the major axis, we also have the foci, which is the point c, where c squared is equal to a squared minus b squared. And this is important because c defines the ellipse, since any point on the ellipse has a distance to the foci and a distance to the center. The sum of these two distances for any point is always the same. Okay, so after that description, looking at this example, we can see that this ellipse is in standard form and that the larger value is under the y term. So the standard form is this x minus h squared over b squared plus y minus k squared over a squared equals 1. Since the larger value is under the y, I know that this ellipse has been stretched vertically. And since these denominators are perfect squares, a squared and b squared, I'm going to rewrite this example and rewrite those denominators as perfect squares. So this 4 is 2 squared and the 9 is 3 squared. From here I have everything needed to create the graph. Our center is the point hk, and since the standard form is minus h and k, we have here minus 3 and minus 3. So our hk is positive 3 and positive 3. Our center is at 3, 3, and then a is the larger of these two denominators. A squared is 3 squared, so a is 3. And 3 is the distance from the center being stretched along the y direction. So this is 1, 2, 3 above the center and 1, 2, 3 below the center. This is our major axis. So a equals 3. And we can see that b squared is 2 squared. So b is 2. This is our minor axis. We would go 2 spaces to the right of the center and 2 spaces to the left of the center. And we now have 4 points that are on our ellipse. Connecting those in the form of an ellipse would give us our graph.